Well, let's take a look at the pigeonhole principle. This is a principle that talks about the sizes of the domain and codomain of a function. Let's suppose we have a function that has 4 codomain elements. If we were to draw a fiber box diagram for this function, there would be 4 fiber boxes, 1 for each codomain element. We have 5 domain elements that need to fill into these boxes. On average, there will be 5 force elements per box. Now, is it possible to have less than the average in every box? No, the average can't be more than what you have in every box. So there's going to have to be a box that's equal to the average or more. Now this is not an integer, so the smallest integer that's bigger than this, there's going to have to be a box with that in it. There's going to have to be 2 elements. There's some notation for smallest integer that's bigger than something. This is like for the ceiling function, like the integer that's above this at least. And in this case, that would be 2. So there has to be a box with 2 things in it. So what does this tell us? If the domain is bigger than the codomain, then when we do something like this, we're going to get a number that's bigger than 1. We're going to have a box that has more than 1 element in it. If there's a box in the fiber box diagram that has more than 1 element in it, that means the function is not injective. And that is the pigeonhole principle right there. Okay, now let's use this same idea in the following situation. What if we have a collection of ID numbers and each one has 5 different positions, and each position could have digits 0 through 9 in it. And suppose we want to know how many ID numbers do we have at minimum to guarantee 100% that 3 of them will agree in their location of zeros. So location of zeros. So for instance, let's take a look at, so we have an ID number here. Maybe we have like 0, 1, 5, 7, 0, and we have another one like 0, 1, 1, 1, 1, or 0 actually. These 2 guys would agree in their 0 locations where there's zeros and not zeros. Okay, how do we do this? By thinking of a function, all right? Every ID number, so ID numbers are going to be like the domain, okay? Every ID number is going to be sent to its unique location of where its zeros are. How can we represent location of zeros or 0 locations? We can do that with maybe a star for not 0 and a 0 for 0. So both of these guys would have this as their code. So both of these would be sent to this via our function of assigning ID to 0 location. Okay, so 0 location sequence, which is okay, that's our codomain. And how many elements are in the codomain? Let's think about that. So there are, every position can either be a 0 or star. There's 5 positions. It's 2 times 2 times 2 times 2 times 2, 2 to the 5th, which is 32. So the codomain has 32 elements in it. So how big does the domain have to be to guarantee that we're going to get 3 of these guys being sent to the same 0 location? That means 3 things are in the same fiber box. So we're going to have a fiber box diagram with 32 guys, okay, 32 boxes, the codomain elements. And we want to ensure that one of these boxes will have 3 things in it for sure. Let's think about averaging. On average, we want to know what's the smallest average so that we're going to have 3 in it. Well, because we're going to have something bigger than or equal to the average, at least we know for sure a box has to have more, at least one box has to be equal or greater than the average. So let's think about that. Let's see, 32, if I go 33, and I have to think, okay, that's going to be bigger than 1, so that's going to force 2 things in a box, just like we had in our previous example. But okay, so in fact 33 is the smallest guy. That'll give you 2 in one of the boxes. If you did 64 over 32, notice this is equal to 2 as well. But because that's the smallest integer greater than or equal to this thing. But what about if we went up to 65? Ooh, I think that's the smallest we can go right there, because that'll actually take us up to 3. So 65. So the answer to this is we need at least 65 ID numbers to ensure that one of our fiber boxes will have 3 things in it. Thanks for watching.